Thank you.
Thank you very much.
Well, I've never had an intro before like that. So here we're talking about exactly that, AWS Step Functions, and how you can make your security tools work with it. I'm Justin Massey.
I'm Jules.
We are security engineers at Datadog. Our day-to-day goal is to make all securities, all of product teams' life easier. And we do that by securing all the things. In this specific project we're talking about is developers owning the security of their application. So our developers in our company, we practice continuous deployment, which we also means that our development teams also own the uptime of their application to make sure that if they deploy something that they are meeting their SLAs. We also want the development teams to own the security of their application. And in order to do that, we must, I've heard, think over and over and over, move further to the left, right? Finding the bugs early and fixing those bugs early.
So obviously, to make it so, there's a lot of security tools out there that will help you find the issues that you have, then you can surface to the developers. And as we just said, CI/CD is very commonly used for developers to test and ship their software. But somehow it feels like security tooling and CI/CD have had some kind of a love-hate relationship so far. So what we mean from that, first off, is that many security tools don't integrate well with CI/CD. Very long-running jobs, a few minutes, few half hour, a few hours even. It doesn't work well with the CI/CD. You don't want your test to take more than a small amount of minutes. You also have a lot of false positives, and in a CI environment, you don't want your test to fail for false positive or non-valuable reasons, so it doesn't really work well. And the third problem is also that each tool has its own way of giving a report, so it makes it very hard to understand and makes it very hard for the CI to actually probably fail or not, depending on the report. So a small example that we're gonna look through during this presentation of such a tool is Checkmarks. Checkmarks is a static analysis tool that gives you insight into your code, but it feels to us that it doesn't integrate well with a CI/CD environment, or at least for us. And so we'll go through this tool to explain how we made it better, kind of. So sometimes the tool integrates with CI/CD, but they just don't integrate well with developer workflow, which is the second very important part for us. What we mean by that is that the tools will block the deployment pipelines. So whenever a tool finds a vulnerability, you might not want to block the pipeline. Vulnerabilities have priorities, they have importance, and not everything is critical. We all know that. So if it's critical, you might want to block, but whenever it's low, you have a vulnerability management program, and you might want to fix that in the upcoming week, upcoming month. So obviously, it doesn't work well for the developers. Also, many of them are sending their reports on a third-party website, and there's a lot of tools already. I think the developers don't really want to click on another website for each security tool. So it makes it very hard for the developer because it doesn't integrate well within their workflow. So an example of such a tool is Snyk that we use at Datadog. Snyk is great. It gives you insight over the vulnerabilities of your dependencies that you use on your code. But the way it integrates with the CI/CD is that it will block the pipeline if there's a vulnerability. Otherwise, if you only say block on certain priorities, it will show that everything is fine, and your developers might not even know that there's low or medium issues that are surfacing. And also, the reports are on the third-party website. So we wanted to make it a bit better.
So I was working on the Checkmark solution and trying to find a way to make it work with the developer workflows. And the Jules came to me, he's like, hey, I'm also doing the same thing for Snyk. So we had another coworker who was working on container scanning, and all these felt very similar. And we wanted to make sure that we weren't recreating the process for each and every one. So we wanted everything to be like a plugin based workflow, similar to CI/CD, but something that allows longer scanning runs, or let longer scanning jobs to run. So the first thing in the workflow was your triggers. This is where everything starts at. So it could be a Slack webhook. So maybe in a Slack app, you say, "Hey Slack, scan this repository." All right, that may work well. Or you may have something like a GitHub webhook that could be on a pull request. Whenever the developer makes a pull request for a new feature, you can go and scan that feature branch versus the master branch. Or you may want to do something like once that PR is merged into master or production, you are then going to do the scan. The next step is the processing part. Now, the processing is the core of what we think about when we're doing scanning. This is, we talked about checkmarks and SNCC. That is where this scanner is going to run at. And all of these, like I said, we want to emphasize that these are all modular. These are plug and play. You can drop your scanner in right here. So the processing is going to take the input from that webhook and then is then going to do the processing on it, and then it's going to prepare the output, which is the result of the scanning engine, and it's going to send it to the output of this workflow. The output could be a comment on a pull request from this bot, or it could be a Slack message to a developer saying, "Hey, you just added 2 critical vulnerabilities," or it could Slack your security team. It could do anything, and you can develop these anyway. That was our goal. So our solution. This was a first take at it. We wanted a pull request to come in, and we wanted to subscribe to the webhooks for pull requests, and we wanted to pass them to the Amazon API gateways that would then fire a Lambda function. That Lambda function was going to do a couple things. It was going to call to make an API call to the security scanning tool that we were using. This is once again the plugin. This is just like the drag and drop. This is like the processing part of it. The input would have been the pull request. This is the processing part. Once the scan is complete, the Lambda function then calls the output, which here is going to be a PR on a comment. Issues with this. The time. Man, these scans, when we were running checkmarks, were taking a lot of time. Just to show you how long, 5 hours for a scan at first. 5 hours. That was not going to be acceptable for us in a CI/CD workflow. And even in this, the Lambdas time out after 300 seconds and actually just up to 15 minutes now. Someone was going to call me on that, I know. Fortunately, one of our guys for our company was like, "You might want to update that to 15 minutes," because Amazon just changed it recently. But the issue is that the longer it runs, it's not doing anything. It's just waiting on that scanning engine to finish, right? It's just kind of sitting there, because we'll go in more detail in a little bit why. But if it's not doing anything, let's wait and then spawn it again. The next issue was that we wanted to have that scanning engine like notify us, say, "Hey, I'm done," so we could fire that next Lambda function rather than having it run for that 300 seconds or 15 minutes. So unfortunately, we had no way to do this. So that was our second problem.
So to first implement our solution, after that, as we said, even though we had issues with Lambdas, we decided to keep Lambdas for several reasons. The first one, it easily scales to a reasonable amount. When I say reasonable amount, is that we're being triggered on GitHub pull request or commits. If it's 10 PR an hour, that's fine. It can grow to 100 or 1,000. That still works. We're not talking about growing to 1 million. So we're staying within a reasonable amount, and for that, AWS Lambdas worked very well. It's also very low maintenance, very easy, and as we say before, with this plugin architecture that we had, it makes it very easy to have the trigger being a Python Lambda and the processor being a Go Lambda, and so it makes it very generic and very plug and play more easily. So we decided to go with Lambdas, and since we had those timeout issues and all those tasks, we decided to create a workflow based out of Lambdas. Have a Lambda do the trigger and then trigger another Lambda that will do the processing and so on. So we started by drawing our ideas on the whiteboard, and it's quite confusing, but if you clean it a bit, you end up on this small architecture where every Lambda will start its execution by retrieving a state in the workflow state in the DynamoDB, do its processing, whatever it needs to do, execute the code, And then once it's done, save the workflow state to DynamoDB and trigger the next Lambda. And the next Lambda will start by retrieving the workflow state and know what it needs to do and continue. So with that, it's fairly easy for us to create several Lambdas working together, bypassing kind of those timeout limitations, and eventually have retry. So I can say, I'm 50% done. Here's what I did. Here's what I need to do. Let's trigger myself again with the actual state, and it makes just a long living Lambda. So in the end, once we've done that, we realized that we just recreated AWS step function. Not as good as step functions. We were lacking a lot of features, and when we discovered step function, we jumped on it right away and thought it was what we needed. So how does AWS step function works? AWS step function defines a state machine, which is a workflow using the Amazon state language. So this is a JSON-based language that you will use to define what are the steps, how it works, and how it all should be displayed together. So each step of this workflow is an individual state, and you also have access to the step function console, which kind of works like a state machine GUI. So you will see what your workflow looks like, and on each execution, which steps were taken, what is the input and output of each step, and if it failed. So what are the different states that are possible? The first one is a task. Task is a piece of code that you run. That's the core and the logic of, the core of the processing of your step function. You can have choice, which basically will run step A or B or C, depending on one of the value of the variables of your step function, your execution. Pass does exactly like pass in the programming code, nothing, but still allows you to handle and do tricky stuff to the state of the workflow. Delay allows you to introduce a delay, and that's pretty cool because you're not paying for that delay. So you want to do step A and then do step B half an hour later, just put a delay of 30 minutes and it will just wait and trigger again. Parallel allows you to start branches and do things in parallel. So it's very nice for our scans, because if we have 10 scans, we can do the 10 scans at the same time, and we don't need to wait for check marks to finish the scan to run Sneak. And then success or failure, it just stops the workflow completely and gives the state to AWS step function. So now that it's said, here's how it looks like. Very simple AWS step function on the console. Start and end of the state machine. Each step in the middle is an individual state. And so here, for example, we have the GitHub trigger, gets the data from the step function, from the execution, will pass its output to the Slack sender that will then start a Slack message. And in our case, what we're gonna talk about today looks like that. So we're gonna dive a bit more into the details, but first, let's do a small demo.
Do we have the? So first, before we start, can you pause it? The lower part we're looking at right here is the developer's terminal, and above is the actual the execution, that specific state machine that is fired. So we've subscribed to a pull request. So a pull request is already made. Now a developer is then going to add a commit to that pull request, and he's going to push it. So that's what we're looking at down here. Is right now git push origin head. So Jules, let's go ahead and play it.
So the developer pushes his new commit, and the top part is really what's going on in the background. You don't need to look at it when you're on a day-to-day basis, but that's how it works. We check the execution of the step function. We can see already which steps succeeded and were triggered, and so it gets refreshed pretty often. So here, for example, we can see in blue that Sneak is running, so the scan is being run. And it allows us to really easily understand what's going on, where are the failure, where did it stop. Now Sneak is done, the PR commenter is being run. And so here we already had the trigger, all the parsing, already did the scan, and now we've sent the message. And here is on the GitHub PR, the output of our scan, and Sneak here we can see the vulnerabilities that were found on our testing project, cryptography, for example, that needs to be upgraded to version 2.3. So this is how it works. Now, let's dive a bit more into how it works. So the first thing first, we have the GitHub authorizer, first step of the function, which will allow us to know whether or not the request comes from GitHub. It's done through a signature, HMAC signature, and if you're used to API Gateway, you might wonder why we didn't use the Lambda authorizer. So API Gateway has this in embedded authorizer, and we couldn't use that, and that was the first problem we had. Integrating GitHub and AWS seems kind of incompatible by default. If you look at the GitHub documentation, they use, as I say, HMAC signed events. So they will take the payload of the event they send you. You give them a secret when you set up the webhook, and they will use that secret to generate the HMAC signature of your payload and send that in the header. So you need both the header and the request to actually validate the payload. If you look at the AWS API Gateway authorizer documentation, you have two kinds of Lambda authorizer. The first kind is a token that will only get what's passed in the header. Doesn't work for signed events here because we need the payload, but it works pretty well for API keys, JWT tokens, so here it just doesn't work. And the second type is request. It sounds great, but what it actually gives you is request parameters, context parameters, query string, headers, but it doesn't actually give you the body of the payload, the body of the request. So the authorizer just doesn't work with GitHub signed events. So our solution was to use this custom authorizer as the first step of the step function. And then based on the answer and the output of this authorizer, we have a choice between yes, I should proceed, I should continue, or no, I should stop. So here's a small code snippet of how it works. It's pretty simple, pretty straightforward. You generate the HMAC of your payload, get the actual signature from the header and compare both, and then return true or false. Don't forget to send metrics if you want to know whenever it fails and why. But yeah, it's fairly simple. So now that the payload is verified, next step. Next step is the actual beginning of the workflow, so it's the trigger. We have the GitHub trigger, which from the event will fetch every information we want. Name of the branch, name of the repository, name of the user, number of the pull request, every single information that our scan will need to run. So once we've got all those data, we have the sanitizer. So the sanitizer is a small step that clears a bit the actual data that you had in the input. So the memory of the state function, the size of the state of the step function is limited. So if you want to have free memory for your scans, you want to free memory before and clean it a bit. So it removes any unnecessary variables from your step function state to let the memory free for the scans. So it's actually a pass task, but it could as well be a Lambda. Next step is the scan filter. This is first logic in our step function. Depending on the information of the trigger, it will decide whether or not each scan needs to be run. So for example, if I'm not modifying any dependency file, there's probably no reason to run sneak. So this is the first logic that will decide what's going on later on in the process. Now we start having the first part, which is every scan and the branches. The scan filter just takes the output from the step before and decides if it should stop now because we don't need to scan, or actually run the scan. Sneak here is the real processing unit in the workflow. It actually realizes the scan, does the scan for us on the code, and will give it its output to the PR commenter, which is the actual output of the step function that will send a message on the PR, on the pull request of the developer. We also have an error handler, which is a catch-all, and catch-all is very important in step functions. So if one of your steps fails, it will show as failed, but the way step function works is that it will stop everything. So if you have 10 branches and 10 things in parallel, a single one failing stops everything. So if you have 10 scans, if one fails, you don't want the 9 others to fail. So what you want to do is have a catch-all that will alert you or let you know through metrics or a message, but you want to actually catch those issues so that it doesn't stop the workflow. And so here the scan and the diagram is pretty easy, and this is how every scan should be, but it's not always that easy.
So check marks is a different beast. Its scan times, as we saw earlier, can take up to 5 hours. We need a way to solve that problem. We also need a way to work with it, even if we can't get it down to a typical build job, which is typically you're seeing around like 3 minutes. A developer doesn't want to wait much longer than that. So the first step in this process is that scan filter Boolean check. Previously, in the SNC filter or in the scan filter step, we did some logic saying, all right, if I want to do a scan on a checkmarks job, or if I want to scan this repository, maybe I only want certain files. I only want to trigger that job if certain files were modified, or if certain languages were modified. So you can do like, if the diff in feature branch and master doesn't contain any changes to Python files, don't start the scan. No reason in wasting checkmarks' resources in doing that. So that's one thing you can do. Checkmarks, if you are implementing it, we can talk later. I can go into the more details, checkmark specific things. But the next step in this, if the answer is yes, you're going to go to the next step, which is to create the scan. There's some metadata related to the project ID that we map to the repository. So we say, all right, checkmark, start this scan on this project. And then checkmark says, okay, I'll start that scan. I'll give you an ID back. Now, it'll sit in the queue until it's ready to scan. And what we do next is we check the scan. We say, hey, checkmarks, that scan ID you just returned to us, is it complete yet? If the answer is no, we wait 1 minute, wait 5 minutes. You can configure your time for however long you want to wait. There's that delay we talked about earlier. We can wait and execute it at a certain period of time later. So then it'll check the scan again. Now, if the answer is yes, there are two things that can happen. There is, yes, I'm done, and the scan completed successfully, or the first scan we do is always an incremental scan. We want it to be as fast as possible. We don't want to do full scan unless absolutely necessary. But checkmarks has by default, there is a 6% code base change. So if for some reason a feature changes 6% of the code base, unlikely if you're working on a big application, checkmarks will say, hey, I need to do a full scan. So after you get that back, we go to the scan choice. And the scan choice, if the answer is I need to do a full scan, it's gonna go back to the create scan step with and it'll say, hey, checkmarks, create a full scan this time. Or if the answer is no, I am done and I have a report, we then go fetch that report, and the report is then sent, and we do, at this point, checkmarks will sometimes give you vulnerabilities that aren't related to the code that was just changed, and I'm not exactly sure what's going on in their backend. I'm like, dude, we just gave you essentially a diff, and you found vulnerabilities that are unrelated. So what we do at this point is we say, hey, checkmarks, or to GitHub, give me the files that were changed in that diff, and then we'll check them against what checkmarks has actually found, and we'll make sure that we aren't going to tell the developer to go change something that he didn't just change. Does that make sense? It's kind of complicated. I'm getting a lot of head nods. Yes. Okay. Cool.
Makes sense to me.
So then we'll use that PR commenter bot that we showed earlier in the demo to go in and say, here was the source line that was affected. Like, this is where the input came from, and here's the output. Like, here's where it's actually going to get executed. And the developer's like, oh crap, that's bad. Now let me go fix it. Or it could, in this one it's just PR comment. But error handler. There are some times that your jobs run into issues, which Jules mentioned earlier. This is our catch-all. So if exception star happened and we aren't catching it any other way, we pass it to the error handler. Well, if you want to filter through all of these different Lambdas logs in CloudWatch, have fun. So we have to find a way to sift through logs. So the first thing you can do is push all of your logs. You can ship all of your logs from CloudWatch into a log management solution. I work at a company that does log management solution, so we use ours. But you can use anything. I can't stand vendor talk, so I'm not going to go into the details. But you can use whatever you want. And this is the graphical user interface of inside the AWS console that we saw earlier. But right here, you can click on a specific step. And if that step is a Lambda function, it'll look like this. So you see that resource, which is that Lambda, and you can see the CloudWatch logs. And here's where you could actually dive into that specific Lambda's CloudWatch logs. But we have the issue now, whether it's in your log management platform or you're looking at it in this CloudWatch logs. If you've ever dealt with Lambdas before, you know that if that Lambda fires at the same time another Lambda fires of that same Lambda ID, your logs are going to be like right on top of each other, and it's going to be very hard to see which one is associated with which. They make available what's called an execution ID that you can add to your logs if you want, but it's very hard to like go through these logs. So the next issue we had was we're like, all right, I don't only want to look at that one Lambda function. I want to look at the entire step function state. So we were like, all right, AWS, we know you've provided this unique ID for that state machine. So let me go dump all the things you've given me in the Lambda function. Event, context, those are your two things that are made available. Well, unfortunately, it doesn't exist. This made things very difficult. We had no way to track that through because I was like, all right, I'll just log it in every single one. So we had to find a solution. Our solution was to generate that unique ID in the first Lambda. So that GitHub authorizer we talked about earlier, the very, very, very first thing we did was to add that state ID. And then what we did was we wrote a custom log formatter, and we made available to that formatter a state ID, and we also have in here a local environment variable called stage, and that environment variable stage tells us whether it's our prod or staging that we're debugging or whatever. So we overrode the logging filter class, and then we were able to use those state IDs that we passed through to each and every Lambda function, and we were able to use that right there in the logs. So if you go to your log management tool and you see one state machine ID, you can filter it. So that's what we do right here. Now this is just an overview, a very broad picture of the log management tool. And if you zoom in really closely, you'll see dash prod dash ID. Now the prod is the stage that we used, and the ID is the ID of the actual execution. And at the very top, you'll see the PR commenter, and the PR commenter was that last step that's going to make the comment. And below that, you'll see check marks. So you're able to see that all of these logs for the entire state machine are visualized right here. So if you do run into an exception, or you do want to see what's going on with that, if you log it and you log that ID, you can follow it all the way through.
So now that we have, it wasn't easy, but now that we have a way to scan and run all of our scans on every code change from our developers, we have the last part, which is maybe the most important. How do I give those issues to the developers? How do I surface those issues? And obviously it's not easy. We need to keep in mind that the developer is a very important part of the project. Their engagement is crucial because, as we said before, we want the developer to own the security of the application. We cannot be there every time. And if we want them to own the security of the app, it means that their engagement is very, very important for us. We don't want to end up in this adversarial situation where security team yells at developers telling them, hey, you should fix the issues, and developers telling the security team, no, I'm not doing it. So we want to avoid this adversarial situation. So we need to give the results in the best way possible. What it means is we want to be low noise, easy to read, where the developer is. Globally, we want to be low friction. The more friction we had, the harder it will be to have a good relationship. And now we also want to make the issues actionable. If I tell the developer, hey, you have an issue here, it's a true issue, and so no false positive, low noise. It's exactly where you want. Everything is he understands everything. But if there's no remediation, it's useless. It's good for your vulnerability management program. It's good to know for your security team. But if you don't tell the developer how to fix it, it's useless. So we need to be a low friction and make issues fun, actionable. In the end, we want the developer to be our customer. And it might sound strange, but as a company, you want to make your customer happy. As a security team, you want to make the developer happy. And if he's happy, he will help you, and you'll end up in this good relationship where developers and security team works together. Now that being said, it's not that easy to do. And how do you know how to give that feedback to the developer? Well, you reach out to them. They are the best source to tell you how they want the results to be given to them. So one of the first ideas we came up with, might sound crazy, is send an organization-wide email, engineering-wide email, asking for feedback. And you might say it doesn't work. You will almost have no answers. But even if you get 2, 3, 4, 5 answers, it's already a lot, because you don't need every single person to tell you and give you feedback. You only need a few of them to be willing to explain how they work and what's good for them. Only a few answers already works. Second idea is application security focus group. Try to gather with some people from your engineering organization, hopefully that represent a broader part of your organization, and discuss with them, explain them what you're doing, why you're doing it, and try to get their feedback on how do they want to help you, how do they want to fix the issues, and try to discuss with them directly on how to solve your problem. And also a very nice way is direct discussion with the developers. You shouldn't stay within security folks all day long. Try to discuss with them around a coffee, after lunch, after a beer, after work. Discuss with them. Try to make them understand what you're doing and get their feedback. And try to also understand and hear what their pain points are during their daily day as a developer. One of the good thing about direct discussion with developers is that you can have them beta test your app. It's like a startup that has clients which will give them feedback to make their app better. It's exactly the same with developers. And here, for example, is a small code snippet where I'm just doing a feature flag on certain characters. So here, if the branch is from the certain developer name, then I will give the feedback and I will trigger this workflow. If not, I'm not doing it. And so it allows you to deploy this workflow to a certain amount of people only before deploying it broadly. So giving their feedback is very important. Another thing I wanted to talk about is to follow the workflow. It's very important for the security team to follow the developer's workflow. So if the developers are using GitLab and Jenkins, try to use GitLab and Jenkins. Same goes for this workflow. As we said, we're not integrating into the CI/CD because we have long-running jobs. But if your tool can integrate into the CI/CD, if it makes sense, if it's not a pain, you should, because you should, as much as possible, use the same tool as your developers. Try also to use the same technologies. If they use Python and Go, try to use Python and Go, because it will help you understand what they are facing every day and what are the pains they are seeing every day. The more you follow their workflow, it will help you understand the constraints of the developers, and so you will better integrate. If you don't want to use your tool yourself, the developers won't use it as well. So it's very important to try to do the same thing as they do. So what is our current solution? Our current solution, as we said, is a comment on the PR, because this is where the dev is looking. We don't want the dev to connect to another website to get the information. Every developer is doing a pull request before merging to prod. That's where they get feedback from their peer developer, they get reviews. So that's where they can see the issues. And here, for example, we can easily see that cryptography is outdated. We have the actual version, 2.2.1, severity. Severity helps them prioritize the work because not everything is critical. And the link is always nice because some developers, and many of them actually, want to know more. They are interested in security. So give them a link so that they can get more information about the actual problem. And then the affected version is very important because you give them right away what they need to do. Here, I need to upgrade cryptography to version 2.3. And what is our plan for the future? All the scans in a single command. That's something we want to do later on. We think it's pretty important if you want to be low noise, because as you saw, each scan has its own PR commenter, because we don't want to wait for all the scans to run to send the PR comment. So have all of them in a single comment. It's not that easy, but it's very it gives a lot of added value. And also auto-fix PR, creating a link for review. It might sound crazy and kind of like, hey, fix automatically all the things. The idea behind that is, for example, for sneak and dependencies vulnerabilities. As I said, cryptography, we know that we need to upgrade to version 2.3. Updating a dependency is not that hard. In the requirements file, for example, for the dependency file, you can change the version. You can do that automatically, create the PR, have the CI run, and then link it for the developer so that the developer can see, did the test fail because there was some deprecation or breaking change in the dependency? Or did it pass, and is it safe to merge or not? So it's an automated part of the actual work of upgrading a dependency that, if it can be automated, do it, because it will help your developers.
So finally, the deployment. You want to take what you learned from here today and you want to go apply it in your shop that you work in. Our goal is to be able to open source this, no promises, but if you do want to go ahead and get started, there's a couple things you're going to need. The GitHub authorizer, and to get so that's the piece that we talked about to make sure that it truly is a pull request or a webhook from GitHub. There's the GitHub trigger. That's actually the piece that pulls the information out that we need, like the pull request, who made it, the features. Now we have here the plugin that uses the Ghost security scanner. We understand not everyone is going to have check marks. Not everyone is going to have SNCC. You can use open source tools with this. There's no problem with that. So this one, Ghost Security Scanner, formerly known as YAS, great tool to check for vulnerabilities in Go. You can use that if you use Go. You would need a GitHub PR commenter or the final one to make that push to the comment. Or you could use something like Slack output so you can notify the developer who just pushed that. Internally, we use serverless to deploy the Lambdas, which you could do with Terraform as well, but we find serverless is easier to manage Lambdas. And we have the step functions, that's the actual state that ties the Lambdas together. We have the API gateway, which is that piece to open up the step function to the world so that GitHub can actually send your webhooks, and the IAM policies and roles to attach to everything to make everything work. And we use Terraform for this to deploy all this infrastructure as code. So
for the case of Sneak, we have a Slack integration, so we get a Slack message whenever something is found on an old dependency. We also use GitHub issues to track vulnerabilities. So the goal is to create, this is not very dev-facing, this vulnerability management program. So we could do it the way we want, and so we want to create an issue so that it gets tracked in time.
Issues for us in GitHub, that is something the security team has gone in and 100% validated. Like we've taken a report from the bug bounty program, we found something internally, we then go write it up and put it on there. This is so fast for the developer that he gets it right then and there, and he may be able to close it before it's even done, but before we're even able to react to it. If that happens, that's even better. I don't need a vulnerability management program if he just fixes it that fast. If we find it critical and we go in and validate it as a security team, then that's when the vulnerability tracking process is going to start, when we're actually able to get in GitHub issues and start that process.
Cool. Okay.
Yeah, but yeah, the tool you showed earlier today, it's pretty neat. So
it's fairly easy if you want to send metrics in the scanners, being like, hey, vulnerability found, send a metric, and so you keep in time when it happened, a log line or whatever. It's probably easy to do that in your scanner if you want.
Other questions? Awesome, guys. Thank you for having us.
Thank you very much.
It's been awesome.